All right, guys, so we got the binomial theorem. The binomial theorem, pretty awesome way to expand some binomials. So let's check it out. First of all, it's a way to expand things, binomials that are raised to powers, like a plus b to the n power. So once you look at these real quick, a plus b to the first power is obviously a plus b. A plus b squared, this is the one we know, like square, multiply, double, square. A plus b cubed, there's a pattern for it. A plus b to the fourth, there's a pattern for it. A plus b to the fifth. We could go on and on and on. Now, one should look for some patterns here. First pattern is there's always one more term in your answer than what your main exponent is. Like a plus b to the first power had 2 terms. A plus b cubed has 4 terms. A plus b to the fifth has 6 terms in the answer. Look at what's happening with the exponents on the first term. Like there's an a, it goes a cubed, a squared, a1, no a. So the a's are going down. Look what's happening to the b's. No b, b1, b squared, b cubed. The b's are coming up. So what we got so far, there's one more term in your answer than your exponent. The a's are decreasing as you go. The b's are increasing as you go. Look at the second coefficient every time. That's 2, look at the exponent. That's 3, look at the exponent. That's 4, look at the exponent. That's 5, look at the exponent. Another pattern. Okay, look at all the coefficients. The coefficients are symmetric. Look, 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 5, 1. They're all symmetric. One more thing, or two more things. Number one, your second coefficient, sorry about that. How do I want to go with this? I think we already said, I can't remember if we said this or not. Your second coefficient, 2, 3, 4, and 5, and these are the same as your exponent. I can't remember if we did that one or not. One biggie that you're going to need, this is going to sound weird when I say it, but your second exponent, like the exponent on that b right here, what I'm circling, is 1 less than the term you're looking at. And that sounds weird, but that's the second term, and the exponent on the b is a 1. This is the third term, the exponent of b is a 2. This is the fourth term, the exponent is a 3. That's what I'm talking about. The exponent on the second variable is always 1 less than the term you're looking at. One more thing here, the exponents in each term add up to be the main exponent. Like this right here, that's 4 plus 1 is 5, look right there. 3 plus 2 is 5, 3 plus 2 is 5, 1 plus 4 is 5, that's 5. Look, go up one line. 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, that's 4. So the exponents add up to be the main exponent. Okay, I just filled your brain up right there. I know we'll work on those patterns some more tomorrow, but the patterns are so important to make your life so much easier. Okay, 2 ways to do these. We're mainly doing binomial theorem today, but there's this thing called Pascal's triangle, which you may have seen before. Also is a way you can like expand these things, okay? So anything to 0 power is 1. So a plus b to the 0 power is 1. What these numbers over here represent, like when I do a plus b to the first power, and I get 1 and 1, those 1s represent the coefficients on the answer. So when I do this one, that's really square, multiply double square, I'll get a squared, 2ab plus 1b squared, right? If I do the cube, it'd be like a cubed plus 3a, remember the a is going down, a squared b plus 3ab squared out of room plus b cubed. So these numbers over here all represent the coefficients in the expansion. Now, one thing about this triangle, the way you come up with it is, that's a 2 right there, and look what's above it, diagonally. 1 plus 1, look at this. 1 plus 2, 3. 2 plus 1, 3. Look right here. 1 plus 3, 4. 3 plus 3. That's how the triangle's made. All right, 4 plus 6, 10. 4 plus 6, 10. 4 plus 1, 5. And it's outlined in 1s, okay? So that's how you set up Pascal's triangle. That's how it's made, and that's also kind of how it's used. Let's try one using his triangle. This one says, use Pascal's triangle to expand a plus b to the fourth. So what I'm doing is I'm finding the line in the triangle that corresponds to the fourth power, and there it is, I circled it already. Now again, what those numbers represent are the coefficients in your expansion. So it starts with a 1, 1a to the fourth. Your second term is always going to be what your exponent is. So even though it says 4 there, I already knew it was 4 because the problem had to the fourth power. Now your a's are going to come down, while your b's are going to come up. When I say that, I mean the exponents on the a's are decreasing while the b's are increasing. I'm going to go 6 next with an a squared and b squared. Notice my exponents add up to be the main exponent that we started with. 4ab cubed, and then 1b to the fourth power. Again, look at those patterns. Exponents add up to be the main exponent. There's one more term in your answer than the main exponent was. The a's are going down, the b's are coming up. And the second exponent in the term is always 1 less than the term that you're looking at. Pretty awesome. All right, this is beginning the binomial theorem. We can't do the binomial theorem without knowing what the binomial theorem is it gives you a way to find the coefficient. I'm using NCR today. Technically, C stands for combination, but we're going to use it today like it's coefficient. Here's what NCR does. And another way to write NCR is put the N on the top and R on the bottom in a parentheses like that. That's what your book is going to use the most. We're going to use the calculator, you're welcome, to figure these out, but that's what your calculator is going to do. It's going to do a bunch of factorials. Those exclamation points are called factorials. So you probably ought to get your calculator out right now while you're watching this and make sure you can punch this in real quick. To do this one right here, to do the one that says 9 over 4, 9C4, we're going to hit the number 9, go to math, prob, make sure you go to prob, number 3, and then hit 4, and I get this, I get 126. Okay, and that's just a matter of punching that in real quick. The second one, 100, math, prob, C, oops, I hit 3 for me. 3, and I get 161, 700. You may want to take a second and stop the video and just make sure that you are really good right there as far as getting those numbers, because you're going to do that a lot tomorrow on your calc. Okay, here's the actual binomial theorem, and you can see they're using these to find your coefficients, and that's really all this is. So it says use the binomial theorem to expand x plus y to the fourth. Here's how we're going to do it in class tomorrow. The first term, obviously x to the fourth. The second term always begins, your coefficient is going to be whatever your main exponent is. Remember, your x's are decreasing, your y's are increasing. The next term is going to be x squared, y squared. Now here we go. I don't know what the coefficient is. That's what this does for me. It tells me what to put in front. I'm going to do NCR. Now listen very carefully. The N is the exponent you begin with. I call it the main exponent all the time. 4, C. Now R can be either one of the exponents you have right there that's in the term. This time they're both 2, so I'm going to hit 4C2. I'm going to go 4, math, prob, C2, and it gives me 6. So my exponent 6. Plus x is going down, y is coming up. Now one trick I want you to learn right here. First of all, I'll do NCR before I show you the trick. So I'm going to do 4C, this time 4C3, punching that in. I give 4. Now I'm going to tell you something. I already knew that was 4. And here's why. Remember earlier, one of the patterns was that the coefficients were symmetric. Because if I look at this second term, and I'll notice, hey, that's x cubed and y, and the coefficient was 4. Look at this term. It was x and y cubed. When the exponents are the same, but they just switch, the coefficients are going to be the same. So that is why I knew it was both 4, because it was both exponents were 3 and 1. And then there's only one more term because there's only 5 terms in the answer. And remember, the y's are going up while the x's are going down, so it's just 1 there, 1y to the 4th. And that's how we're going to expand, okay? Most of these are going to be 1 line, 2 lines at the most to solve these, to expand these things. All right, find the term that contains x to the 5th in the expansion. Okay, they don't want you to work it all out till you get x to the 5th. They just want you to find the one term. So here's what I know. If it's going to be x to the 5th, it's going to be 2x to the 5th. The y, remember the exponents must add up to the main exponent, so it's got to be y to the 15th. What I need to know is what's the coefficient right there that's going to go in front. Now, to do that, I'm going to go NCR. All right, remember that's like this is how your book's going to show you if you look at your book, NCR. Now, N is the main exponent, which is 20. R, you can choose either one of the exponents in your term. You can choose 5 or 15. I'm going to choose 5 just because it's quicker to punch in. So I'm going to my calculator, punching in 20, math, prob, find NCR, which is number 3, hit the 5 or the 15, and I get this. I get 15, 504. That's the coefficient. But I also have this 2 in here that's raised to the 5th power. So I need to do that. I need to do that. My last answer, that 15,504 times 2 to the 5th power, which by the way is 32. And I get, so this is my final answer. I'm going to change colors here. This is my final answer for the term that contains x to the 5th. It would be 496,128 x to the 5th, y to the 15th. So that's the only one of that one term. Okay, so we can find one term doing that way. That's a lot on one video. I know it is. It's a whole lot on one video. But you can go back and hopefully go back and watch it before your test on Friday. And We'll be good. We'll work on it in class. You'll get it. I promise you. It won't be that big a deal once you do a few of them. All right. I'll see you tomorrow.